In this problem, we're given a situation in which a pitcher throws a ball from a height of 19.6 meters with a vertical velocity of 14.7 meters and a horizontal velocity of 43 meters per second. So, I've drawn a little diagram here. Just give us some arrows, give us an idea of what the ball is going to be traveling when it is first thrown. So we know the vertical is 14.7 meters per second, and the horizontal is 43 meters per second. And we were also told that we can assume that gravity is constant at 9.8 meters per second squared. So the first thing that we're asked to find is the function giving the height of the ball as a function of time. And we're told that it will take the form h of t equals negative 1/2 g, or gravity, times t squared, plus the initial velocity times t, plus the initial height. So this is not too difficult. Once we already have this form, we just need to plug in the information that we know. So h of t equals negative 1/2 times 9.8 is going to give us negative 4.9 t squared, plus v0, or the initial vertical velocity, which as we know is 14.7 meters per second, plus our initial height, which is 19.6 meters. So there is our function giving the height as a function of time. So the next part is, what time does the ball land on the ground? In other words, when does this equal 0? And there's a couple different ways that you can do this depending on what materials you're allowed to use. If you have the quadratic equation, you can plug in a, b, and c into that. Or if you have a graphing calculator, you can take a look at that. Either way, it's not that difficult, though a little bit time-consuming and space-consuming as well. So regardless of what method you use, you'll find that this time, which I'll call t star, is approximately 4 seconds after the ball is launched, which may seem a little strange considering that each of these numbers is a decimal, not just an integer, but that's what it comes out to. So, how far does the ball travel before hitting the ground is our next question. So what we need in order to do this is another function that gives us the distance that the ball has traveled horizontally as a function of time. Well, we can assume that the horizontal velocity is constant since we're disregarding any forces like drag. So we know it's just 43 times t. We'll call this just d of t for distance. The distance is 43 meters per second times t seconds. Well, we just plug in our magical t star of 4 and see what we get. d of 4. And we get 43 times 4, which is 172, though you're certainly welcome to check that arithmetic if you don't trust me. So that's part A, B, and C. Next, we're asked to find the critical values for h of t to determine the intervals on which it is increasing and decreasing, and then use that to find the maximum height of the ball. So we'll just rewrite h of t. H of t is negative 4.9 t squared plus 14.7 t plus 19.6. So if we want to find the critical values for this, that means we need to find the places where the derivative is 0. But in order to do that, we need to find the derivative first. So negative 4.9 times 2 is going to be negative 9.8 t. We take the derivative of the second term, it just gives us 14.7. And then 19.6, the constant just drops out. So this is our derivative of h of t. And we want to find when this is 0. So 0 equals negative 9.8 t plus 14.7. We'll just bring 9.8t to the other side. Equals 14.7. Divide both sides by 9.8, and we are left with 14.7 over 9.8, which comes out to be 1.5. So that is when the derivative is equal to 0. So what we want to do is determine when this is increasing and when it's decreasing. So if we have let's make a little number line here. See, this is h prime of t. We want to know when this is positive and when it's negative. Because when this is positive, h of t is increasing. And when this is negative, h of t is decreasing. So we can just plug in values on either side of this, and it should work out fine. Let's take a look at 1 and 2, the easiest ones available. So h prime of 1 is equal to negative 9.8 plus 14.7. Well, it's fairly easy to see that this is smaller than this, so this is going to be greater than 0. So we know that this is positive here. And then let's look at h prime of 2, which is going to be negative 9.8 times 2 plus 14.7. 9.8 times 2 is 19.6. Here, the negative term is larger than the positive term, so it's clear that this is less than 0. Okay, so let's just write out what the intervals are in which h of t is increasing and decreasing. So h of t is increasing. Maybe tempting to say that this is from negative infinity to 1.5, but we're only concerned with values of t that are positive, because we're not traveling back in time. So t is less than 1.5. And then h of t is decreasing after that time. And again, it may be tempting to say, well, from 1.5 out to positive infinity. But as we already know, the ball hits the ground at a time of 4 seconds. And we're just going to assume for the case of this problem that it just hits the ground and then stops moving. It doesn't keep bouncing up and down. So on the interval 1.5 is less than t, which is less than 4. Alrighty. So the last part of this step is we need to find the maximum height of the ball, which is simply the height at time 1.5. So I'm going to have a whole lot of room here, but let's get rid of some of this. So we just want to find h of 1.5. Let's see here. Get negative 4.9, 1.5 squared plus 14.7, 0.5 plus 19.6. I'm not going to do this out for you. It's not particularly complicated, but if you have pad and paper or a calculator with you, not that hard to find what this is. But more importantly, let's move on to the last step, which asks us how far has the ball traveled horizontally when it reaches its maximum height. So the piece of information that we need for this is just this number here. Time is 1.5. So we'll just plug 1.5 into our function that tells us how far it's traveled horizontally, which, if you recall from before, we called d of t, which is just equal to 43 times t. Well, we just plug in 1.5 for t, and then we're good to go. 43 times 1.5. Did this out earlier. If I remember correctly, this is 64.5. Should be our final answer. That is the answer to each of these steps of the problem. Be sure to check the arithmetic on your own.